Okay, in this video, we are going to have a look at discrete logic circuit design. Now, I've been asked, do people still design circuits with discrete logic? Because all they see is microcontroller projects online. And I still do. Here's an example of one. I'm going to cover this in this video. So back in the day, before microcontrollers, we designed our circuits with TTL. That's a 7400 logic series. Then after that, upgrade to CMOS, the 4000 series CMOS. And that was brought to us by RCA. You probably remember them. They came out with 4000 series logic. And while they're at it, they actually made a microprocessor, the CDP 1802. So if you wanted to start designing with discrete logic components, grab yourself a bunch of 4000 series CMOS logic and start building. Okay, so here is the problem that we have to solve. Now, on our farm, we have many automatic gates on our driveways to keep the animals from getting out, to keep unauthorized people from coming in. So the guys that come in regularly, like the irrigation guy or the diesel mechanic or the produce truck, we give them a fob. It's like a garage door opener, so they can open up the gate. But sometimes we have a truck that comes to the gate that has never been there before, and he gives us a phone call. He says, I'm at your gate. So we got to run out there and open the gate for him. So we came up with a solution that if the guy would beep his horn 3 times, it will open the gate. So we could just tell the guy, honk your horn 3 times, the gate will open, and you come in. So that's the problem we have to solve using our circuit, our discrete logic circuit design on my breadboard. Okay, here's a block diagram of our system. Now the top part is existing. So we have an RF board, and in my case it's made by LiftMaster. So when we activate the fob, it receives it on the antenna and it activates a relay. So we have a contact closure for about 1 second, and that's going to short out 2 terminals on the control board. And that will start the sequence of opening the gate. So the gate opens, and then there's a presence loop. It's a metal detector. It sees that if there's a car there or not. It waits for a car to leave, then it'll close the gate. Now my add-on is this board here. So I have a microphone like this. So that picks up the horn, and 3 beeps, it's going to activate a relay, same thing. And it's going to short out the same 2 terminals on the control board, which will open the gate, check for presence of a vehicle, and when it's gone, close the gate. Okay, so let's check out how this circuit works. Now when I was designing the circuitry, I did not use my microphone module. I didn't want to be beeping a horn every time I wanted to test. So I replaced it with a touch switch, which gives the same output. So when I touch the switch, that's the same as beeping a horn. Now this LED here is the drive to the relay that gives the contact closure to open the gate on the control board. So if I beep my horn 3 times, the LED will come on for 1 second. There it is. It drives the relay, which opens the gate. We'll do it again. 3 beeps. Now a car horn could beep faster, so we do 3 fast beeps. Opens the gate. Now a truck has an air horn, so the beeps are longer. So 1, 2, 3. Now what happens if we beep 4 times? 1, 2, 3, 4. Doesn't pick it up. I'll do it again. I'll do it fast. 1, 2, 3, 4. So if we get continuous beeps, let's say a wedding procession is going by and the guy's honking his horn, or if you have a car with the alarm going off by your place, it's not going to activate the relay. So it's pretty smart. It wants to see 3 beeps, and it activates the control board, which will open the gate. Now the 3 ICs I'm using is a CD4538. That's a dual monostable. The next IC is a CD4093. It's a Schmidt-Trigger NAND gate. And the last chip is a CD4017. And that's what's doing the counting. It counts how many beeps. So when I do 3 beeps, it actually detects that, and LED comes on to open the gate. Okay, so let's talk about the beep counter for a second. So here's a simple block diagram. We have a microphone that picks up the horn. So after 3 horn beeps, it's going to turn on this LED. So in the simple circuitry, what could happen? A car could drive by and it could beep at a dog on the road. So that's beep number 1. 10 minutes later, another car could drive by and beep at a friend. That's 2 beeps. And then another 10 minutes go by, and another car drives by and beeps, and that's 3 beeps, and it'll activate the LED. So we don't want that. So we create a window, and this window is 5 seconds, and it's controlled by a monostable. So the first beep will kick up the monostable. So now you have 5 seconds for the next 2 beeps. Then the monostable will drop down and reset the counter. So with this window in here, we won't get the problem of having 3 beeps counted over a long period of time. It's only within the 5-second window. Now when designing logic circuits, all you need is a good logic probe for troubleshooting, which you can see here. Now this probe is from Heathkit. I've had it for a long time. Some of you know what I'm talking about. So right now we're going to look at the monostable that gives us a window, a 5-second window. So I'll beep the horn and you'll see it go high for 5 seconds and then drop down again. So I'll give it a beep. So it goes up, goes high, 5 seconds later, down, do it again. High is our window. Now when it goes from high to low at the very end, it will give a pulse to the 4017 to reset it. So we can look at that reset pulse. So right now it's low. So I'll kick it up. Now after 5 seconds, when it drops down, you'll see a small pulse. Right there. Do it again. Goes up for 5 seconds. When she comes down, it resets the counter. Okay, here's the full schematic of the circuit that I built on my breadboard. So you could freeze it here and go through it yourself. Then I'll go through it section by section. Okay, next, we are going to have a look at the operation of this circuit. So here's our touch switch, which simulates the horn. Every time we touch it, we get a clock into this monostable. Now this monostable creates our window. So she'll kick up for 5 seconds, well actually 4.7 seconds. 470K times 10 microfarad will give us 4.7 seconds. So she'll go up for 4.7 seconds and come down. As she comes down, we're going to get a pulse generated by this circuit here. This is called a half monostable with a 0.1 microfarad capacitor and a 22K ohm resistor, which is edge triggered. And that'll give us a pulse, and that's fed down to reset to 4017. Now the 4017, you've probably seen these as LED chasers, where you clock it and you'll see the LED being chased one at a time. So when it's reset, pin 3 will be high, pin 2, 4, 7, and 10 will be low. So on the first clock pulse, pin 2 will go high, second clock pulse, pin 4 will go high, the third clock pulse, pin 7 will go high, so that's 3 horn blasts. And if it stays at pin 7 long enough for this RC time constant, it's going to trigger this monostable, and its RC time constant is 100K times 10 microfarad. That gives a 1 second output, so that's going to drive the relay for the gate. Now, if we do 4 pulses, it's going to go 1, 2, 3, 4, and it's going to end up on pin 10, and that's going to feed. It's going to feed a high into the clock enable. That's going to disable the clock. So once we get a high on pin 10, we could clock this as much as you want. You can honk the horn as long as you want, and it will always be locked until we get the reset. Then it goes back to pin 3 going high, ready for the next 3 clock pulses to operate the gate. Now also there's a power on reset. Now we need that. So this will generate a pulse into the 4017, and it'll reset it on power up, because if you don't have this, the first time you try it, it won't work until it gets the pulse from the monostable. So usually when you have logic like this, you always have a power on reset with an RC time constant, and that pulses the reset pin on the 4017. Okay, so that's how you make digital logic circuits act like software. Now when I did build these boards, I built my own microphone amplifier that had filters that would be more sensitive to horns, so somebody clapping their hands couldn't activate it. Plus I put it in a PCV pipe to make it directional, and I had a timer on it so it shut off during the night, so it was only active during working hours. Now the last few videos that I have made, they were requests from some of my friends who are students, hobbyists, members of some of my clubs, and that's how it's going to be from now on. Because before, when I made a video, I had to put a disclaimer that it's a beginner's video. Otherwise, people who are advanced would say, oh, I already know that, you're wasting my time. or if it was too advanced, they would complain it's it's over their head, they don't understand. So this way I know if I'm making a video, there's somebody that's going to get something out of it. Now I notice YouTube is noticing this because there's a lot of electronic channels shutting down, a lot of good ones, some of the ones I've been watching. So they've taken away the dislike counter on viewers, and now they're taking it away actually on the creators. But still, I think you can't make everybody happy, so I think people are burning out and they're shutting down their channels. So I'm just saying that there might be long intervals between my videos that I'm making for my friends.